My name is Sigurd Flågan, and I am a PhD student here at the University of Basel, where I work in the group of Richard Warburton, and I'm also a member of the Spin-NANO network. So my material is diamond, and as you may know, diamond in its purest form is transparent, just like a piece of glass. So then you may ask, how does diamond used in jewelry get the different colors? And to answer these questions, you have to look at the diamond structure itself. Diamond is made out of carbon atoms, and each atom has 4 neighboring carbon atoms. But now, let's say you can take one carbon atom and take it away from the crystal, remove it from the crystal, and then leave the position behind empty. An empty position like this is called a vacancy, and it's a type of a crystal defect. If we have this vacancy and we take away a carbon atom next to the vacancy and replace it by a nitrogen atom, then we create another type of crystal defect, and we call this for a nitrogen vacancy center, or an NV center for short. And this NV center interacts with light and hence give the diamond a color. So we can use the light emitted from the color centers in, for example, quantum communication, but the color centers does not emit light by themselves. We need to somehow excite them, and in our labs we excite the color centers using a green laser, and then we excite the color center. It emits single particles of light, which we call photons, in all directions and with a range of colors. But for uses in quantum communication, quantum technologies, it is desirable to have only one specific colored and emission in only one direction. To remedy this problem of this broad emission all over space, we can construct something that acts like a funnel, which then funnels the photons in one direction and with only one specific color. So the diamonds we are using in our experiment does not look anything like the diamonds you use in jewelry. So we start with a flat diamond with color centers already implanted in it, and then we can thin down the diamond and create small plates of diamond. So the funnel I was talking about is created by 2 very high quality mirrors, which is in a device called an optical cavity. So the mirrors are made of an alternating stack of 2 different material, which then gives a very high reflectivity. And then we can take the small diamond plate, we can put it onto the bottom mirror, and then we take a similar stack of material to create the top mirror. In our experiment, we can tune the mirrors and move the mirrors with respect to each other, so we can change the height, also the length of the cavity, as well as changing the position of the top mirror with respect to the diamond. And my colleagues here at the University of Basel have already shown that by changing the position of this top mirror, we can locate single color centers within the diamond itself. And by optimizing the cavity, we had demonstrated that the cavity really acts as the funnel I was describing earlier. So my job will be to take over this project and improve the cavity to get more light out of the cavity. And then hopefully we can turn this device into a useful product for quantum communication. I think that was pretty good.